Alright, I'm Jasmine Smith. This is interactive learning, I'm participating in Challenge 2014. This is interactive learning number 6, and this is problem number 2. So similar to problem number 1, you're also finding the volume of a revolved solid but this time it's over the y-axis. So you have y equals 4x and y equals x cubed, bounded by x is greater than 0. And again, that is about it's revolved about the or rotated about the y-axis. So here's the graph of the given functions, and here you have x cubed. It's kind of drawn lightly, and then darker there's y equals 4x. So you're finding the volume of this part right here revolved about the y-axis. So again, you're going to use the shell method. And that requires, this time it's going to be in terms of x, so it's going to be v equals the integral from a to b, which are the limits, of 2 pi x f of x dx. And again, the x is the radius, and the f of x is the height. And dx, you're just taking the derivative, the integral in respect to x. So, to find this intersection here, to find this limiting point here, you set the two functions equal to each other. So f of x is equal to x cubed, and I moved over the 4x and set it equal to 0, and then I just factored out an x and then expanded the x squared minus 4 and kept it equal to 0, and you get x equals 0 and 2. Well, and negative 2, but you don't use that because it's not in the boundaries of the graph. So what you're going to have here for a and b are 0 and 2 respectively. So what you end up with is v equals 2 pi integral of 0 to 2 of x times 4 of x minus x cubed dx. And the reason that you use 4x minus x cubed is because you're basically using, you're finding the area between the curves. So you have to find like the right curve minus the, the top curve minus the bottom curve. And here you can tell that the top curve is the 4x and the bottom curve, which is below it, is the x cubed. So that is the reason for that. So you get 2 pi, because you just bring out that 2 pi as like a constant, times the integral of 0 to 2 of 4x squared minus x to the 4th, which I just combined these terms with the x dx. So integrating that, again, the power rule, you add a power and then you divide by that power. So you get 2 pi times 4x cubed over 3 minus x to the 5th over 5. And you're going, it's a definite integral from 0 to 2 because you're finding the volume, which is going to be an actual value. So you plug in for 0 to 2, so you're going to subtract what you plug in for 2, and you're going to subtract what you plug in for 0 from what you plug into 2. Yeah. So it's going to be 2 pi times the whole thing. So when you plug in for 2, you're going to get 4 times 2 cubed over 3 minus 2 to the 5th over 5. And then that whole thing minus what basically equals 0. So that cancels out. And so you're going to have 2 pi times 32 over 3 minus 32 over 5. So that gives you 2 pi times 64 over 15. And that final answer is 26.808.